All right, CNT140, we're looking at Chapter 5. So we just got done talking about the different connectors. And again, remember I have pictures here to show you all those. So use those to help sort out the connectors. It is very handy to know what connector you're dealing with. And here I had a close-up again of this is the end of an SC connector. But if I look at the ceramic ferrule, this part that's sticking out, this little part that's sticking out right here at the end, if I look at that ceramic ferrule up close and personal, the ceramic ferrule right there, that's the outside. And then the actual little teeny dot in the middle, that's the actual fiber. Now, you're actually looking at the outside of that fiber, the cladding part. The core would be the teeny tiny dot in the middle of that thing. So, yeah, small stuff. And then again, I had pictures here showing you this ST connector kind of all broken apart. Here's an SC connector all broken apart. Then here's an LC connector broken apart. As we do terminations later this semester, we'll be doing an LC connector, so you'll get to see all those pieces up close and personal. One other fiber connector we want to make sure we're aware of is the MPO, multi-fiber push-on. And there actually is a trademark name for that. Your multi-fiber termination push-on, MFTP, if you will. So this actually I have a fiber, and this is where kind of like your ribbon cable comes into play, where I have one connector that has in 12 or 24 fibers. Here's a 24 fiber connector, or 12 fiber connector and a 24 fiber connector with that ribbon cable into the fiber. So that one connector can be a backbone connection between two closets or two sides of campus. And what typically happens is that cable on the other end then gets connected to a breakout cable that'll break it out into, in this case, it's 12 LC fiber connectors, which gives you 6 connections. So there's your 12 fiber into 6 connections, and then here would be the 24 into 12 connections. And that kind of thing gets used when you're connecting two closets together. And later in the chapter, I have the kind of equipment that this cable would plug into, the kind of cable that would plug into, to give you an idea. Termination of fiber, yes, we need to have a fiber connected, terminated, that we can actually plug into. So I can actually get fiber made to order that'll have the connections on. I just need to order it with very accurate distance measurements. But I can also terminate on a connector too. So termination, the basic process, I have, there's a couple steps here that we're going to walk through. But I wanted to show you here, if I get a fiber that actually has a connector on, I can actually get a pull sleeve that protects those connectors, that I can pull this through my conduit. So I can actually get pre-terminated fiber and have a pull sleeve around it that'll pull through conduit or whatever and protect conduit and protect those fiber connectors. If not, if I'm going to terminate, I'm going to go through a series of steps to be able to terminate the fiber. And it varies a little bit depending on the type of termination I'm using. So one of the earliest forms of fiber connection was an epoxy polish connection. And what happened was you would actually strip the buffer off of the fiber and feed the fiber through the ceramic ferrule out here. That's the actual fiber stub. You would epoxy it in place and then score this and break off the excess. If you've ever scored glass and broken it, maybe for a window, that break at the edge is usually very clear, very clean. And that's the idea here. You're going to score and cleave or break that fiber off, and then you use a polishing process. Think of it as like very, very fine sanding. You're grinding that back to a even with the ferrule here. So you have a nice clean end that you can plug into and use. So here's some pictures of, I strip the buffer off, I then cleave. Once I do that, I can, I strip off the buffer, I can fit it into the connector, okay, fit it in place. The fiber itself comes out the end, sticks out the end right here. You cleave it, and then you go through a process where you polish it back. You put it into a little puck, and you actually use abrasive material to gently grind that back so it's nice and flat. If I do a hot melt, this was like generation number 2. Think of it as like glorified hot glue, okay? The process is very much the same. I'm just going to fix it in with the hot melt. The hot melt gave the advantage of you could heat it up again and readjust the fiber if you needed to. But then the rest of the process is pretty much the same. They made a crimp-on style connection as well. This we actually used for a little while in our lab room. Our success rate was not very high because we were learning to do it, so we didn't have all the fine skills and so forth to do it. But what you had was the connector itself had a pre-terminated fiber in, the red part here. You were prepping the fiber on this end to literally cleave and so forth and slide in here to it just touched, and then you would crimp that in place. And again, we were doing it, but our success rate was not very high. And this is showing it up close here where I prep my fiber here, cleave it, slide it into it, just makes contact with the fiber that's pre-terminated in here. And then you would actually put it in a vise and crimp it shut and slide the protective boot over the end. And this shows you the whole stripping, cleaning, cleaving, sliding in the connector, and then I crimp it in place, so forth. The style we use now, and the style that I think is probably the most common, is the you actually splice on, you fusion splice the fiber on. This is the kind of termination that's done if you have like fiber to the home. They're literally outside splicing the fiber together for connection in your house. This is the kind of termination we'll end up doing later this semester. So with the fusion splice style, the connector again already has a fiber in the connector, and there is a strand hanging out that I'm actually going to prep my cable, and I'm going to fusion splice my fiber stub to the fiber stub they have. Think of that if you've ever been to Boardwalk and you watch people, doing glass art where they're making little, dogs and little cats, and they're taking a glass tube and they heat it up and they stick another one to it and heat it up. That's the idea. I'm actually taking those two stubs, heating them up, touching them together very precisely, stopping and letting them cool and fuse together. That's the process that's done. So to do that, actually here's the fusion splicer. These little arcs right here, these little electric arcs, these little electrodes produce an electric arc across to heat the two fiber stubs. There's one coming in this side, one coming in this side, and it will fusion splice those together for you. So here is the connector. There's the ferrule that actually has, this is actually that part that would plug into a piece of equipment. This is the back of that ferrule, and the stub is sticking out. That's what I'm going to fuse onto. So I get that out and put it in the fusion splicer, that right there. I get it out of the packaging, put it in, and then I take my fiber, I strip off the buffer, clean it, cleave it, load it into here, and the fusion splicer goes through a cycle where it actually takes my fiber here, inches it in next to this is the connector fiber sticking out, and takes those two fibers after heating them up and just touches them together and lets them fuse in place. That is the kind of termination we use, and we actually have pretty good success with this one. We have actually very good success with this one. They talk about different types of ferrule shapes and polishes. There are different types for different connections, and that is also something that is a concern as you're connecting things together. They talk about field termination. Make sure you have the right connector, know how to use the connector, have right tools, dust and dirt are the enemy. Again, do not over polish if you're doing any polishing. Yes, dirt and dust and dirt are the big time enemy. It's even for us as well as we're terminating. They talk about change your polishing film regularly, but we're not doing so much polishing, and cover any connection when you're not in use, and inspect and test. Yes. The book didn't talk about this so much, so I put just a couple slides in here to get you to realize if I have a broken fiber, I might need to splice it together. I always make the joke of, if you've ever seen, you have a backhoe in town and they're digging, every now and then they hit a fiber line, and you'll see some person up on a bucket truck or down in the hole. They might actually be taking those broken fibers and splicing them back together. They might actually be doing that, especially if there was an outage in the area. Well, I can either do a mechanical splice or a fusion splice to basically patch those back together. The mechanical splice, I'm actually going to use some sort of fixture to hold those two fibers next to each other. Again, think about taking two garden hoses and, wrapping some electrical tape around it. And I'm going to hold those two garden hoses together. That's the kind of idea with the mechanical splice. And you have a fixture like so. I load the fibers in each side, and I lock that over top to hold it in place. I even have some that you can glue together in place as well. The fusion splice, just like I did my connector, I'm taking those two fibers, I'm heating up the ends, and the machine touches them together and lets them cool, and now they're basically one solid piece of glass. All I need to do is put a protection sleeve around it. And this is actually the process it's doing to do that. This is your fusion splicer doing that. So I can actually take my fusion splicer and repair fiber instead of just terminating fiber. I can actually repair fiber. And this is actually showing you kind of an up and close and personal. Here's the two fibers coming in. There's the electrodes. A shield will go over top of that. The electric arc will go across there to heat them up. And then the machine, there's very fine motor control. It takes this side, slides it in. This side over here slides in until they just touch. And now they're fused together. And when you're done, you slide this splice sleeve over top. The splice sleeve is heat shrink tubing with a metal spline in. So the fibers themselves go through this tube, and the metal spline is there to give rigidity so it doesn't break, and you put that in a heat shrink apparatus, and it heat shrinks it around. Connector splice and performance with this type of this looks very much like the fusion splicer we have. They're aligning the cores when they fusion splice, and they're actually trying to get near zero loss. And actually you can get extremely close, if not right on the money, with zero loss when you're fusing them together. And there can be issues. Here are some issues that might pop up if your fusion splicer is not set up right, or it needs calibration, or it's dirty. I can get some of these issues come up when I go to fuse, and I might actually see that. I might see a dust error or a not clean termination end. They'll say the fiber end is not cleaved correctly. Okay. And as they're talking terminations, do I need to terminate in the field? Not necessarily. And in reality, when you're working in a network environment, you might not terminate fiber at all. But there might be a group that comes in to terminate fiber for you. But I might even just buy my cabling with the terminations done. Here is one of those MTP cassettes where I think I have, no, I don't have it here. That MTP connection plugs into the back, and this unit right here splits it out into 12 fibers or 6 connections, 2 fibers each. And then here would be a 24. There's a row of 12 up top and 12 on the bottom. So you now have 12 unique connections you can do. There was the connection coming in here, connection coming in here, those MTP connectors. And they talk about actually managing and protecting terminations. Yeah, as I showed you that the splice sleeve, that would go around your splice to protect that splice. But I also have to worry about when I'm connecting and plugging in fiber connections, I need something to protect them. So usually your patch panel has a case around it that's going to support or protect all these connections. As I look back here, all these connections back here are being supported and protected. Here, if I actually have a splices I'm doing, there's actually trays in here where that fiber can lay and be protected so it's not bouncing around and potentially breaking. So there's protections for that. The book didn't talk about a whole lot, but if you're actually installing fiber, they remind us of, I actually tie any pull strings to those strength fibers inside, not the actual fiber optic, those strength fibers inside, and pull it through my conduits. And I remind you about those, the pull sleeve. If I do need to pull fiber with connectors on, I can get a pull sleeve that will go around them and protect them, and I tie the pull rope to the loop on the end, and that'll allow me to pull it through. If I'm doing it off of a spool, I want to actually prop up the spool and allow it to roll off naturally. If I have excess fiber that I need, that I'm in the process of moving, I coil it in the ground in figure 8 so I don't have all kinds of twists and kinks when I then pull it back out to go to the next run. And then here's a reminder about bend radius. As I'm installing fiber, I do need to worry about not bending it too tight. I need nice, big, rounded corners if I can do it. And then here, oh, right here, I skipped right by it, showing you in a tray, this might be my copper cabling here. Off to the side, I might install interduct. This is actual plastic tubing that is designed to protect the fiber. And I can pull the fiber through that tube and have it up in the tray here. But then that actual tube is protecting my fiber and fiber optic connections. And talk about here, try to pull without splicing, etc., etc. All right, we'll come back in the next one here and finish up.